math has been driving you crazy, or if you're finally admitting you're lazy, and your test grades have been dropping, it's time to get your arrows popping.
Hello everybody, how's it going? This is Mr. Witt with Fort Bend Tutoring, and today we're gonna continue. Oh yeah, we are. We're gonna continue with the Algebra 2 end of course final exam review, the second semester final exam review for Algebra 2, and that's what's going on. We got Yo Dude in the house. What's going on, Yo Dude? Obina is in the house. She's early today. We also have Treasure Ghost. And Lewis is in the house. Mr. Diaz is in the house. That's right, Lewis. We had to make sure those technical things were in order before we went live today. Tony is in the house. With Noah is in the house. Go ahead, Noah. That's right. We have it up and running correctly now. And of course, we're going to begin with a shout out to everybody. We got Olivia in the house. Welcome, Olivia. How are you doing today? That's right. Treasure Ghost says, I am not in the house. I'm in a 5-star hotel today. Well, congratulations, Treasure Ghost, for being in that 5-star hotel today. Absolutely. So, ladies and gentlemen, we have some good problems for you today, and we're going to work through them together. That's exactly what's going to happen. And on top of that, I want to have you guys make sure, Treasure Ghost said he was just kidding, make sure that you subscribe to Fort Bend Tutoring. Go ahead and click on that bell icon right next to that subscription box there, that subscription button, to make sure that you're notified when we go live, when we have new content from Fort Bend Tutoring. And in addition to that, please share the stream. I always say scream. Something's wrong with me. But go ahead and share the stream with your friends and family and the people that you love and hate. And that's right. Yo Dude was first, guys. He was absolutely first. What's going on, Michael Burns? All right. What's going on there? That's right. I didn't even see part 2. Oops, you mean part 1. Yeah, make sure you check out part 1, Yo Dude, because we're going to be picking up from part 1. That's right. Okay, so make sure that you guys are checking out the content so that you can have a steady understanding of what's going on here as we continue with part 2 of the Algebra 2 final exam review, and we're gonna start right now, guys. So we got our people in the chat already. That's right, and look at you guys checking us out. That's right. And we got Tony and Noah checking out the stream today. Olivia's in the house too. And let's have some fun. It says that we're going to divide using synthetic division. What's going on, Jamila? Good to see you this morning. Absolutely. We have the quantity of x to the 4th power plus 17x cubed plus 54x squared minus 75x minus 18, and we'll be dividing by x plus 6. Danielle says, what's going on? Hello, Mr. Wood. I just finished my final exams. That's right. Oh, no, Danielle, I hope you do pass. So I'm rooting for you. Okay, so hopefully you did everything that you were supposed to do to prepare for that final exam. Guys, when you're using long division here, you're going to take your divisor and you want to set it equal to 0. And of course, with the synthetic division here, you want to make sure that your divisor is in this format. In other words, that you have x to the 1st power plus or minus a number. That is the perfect divisor for synthetic division. And guys, you can check out my video from Fort Bend Tutoring for synthetic division so you can see more examples like the one I'm about to do right here. That's right. So you want to check that out as you practice your synthetic division. Regina's in the house. How you going there? Noah says, I can already tell you the answer, but I want you guys to solve it. You are on fire already, Noah. Check you out. So I'm going to take this x plus 6, guys. We'll set it equal to 0. Go ahead and solve for x. Solve for x, and you'll come up with the value -6. All right, so that's just for starters. Once you have this, guys, we'll be setting up our long division as follows here. Not the long division, the synthetic division as follows. We'll go ahead and write down our divisor's value there. I hate that. Let me fix it. There you go. This is going to be better. It's going to be better. There we go. There you go. And, oh yeah, synthetic division is a different way to divide polynomials there, yo, dude. That's what synthetic division is. Let's go ahead and check this out. So what you're going to be putting inside of this upside down division symbol right here is all of the coefficients from the dividend. All the coefficients from that first polynomial that they showed you. So we'll have 1, 17, 54, as well as negative 75 and negative 18 will go in that spot right there. From here, you're going to be starting by bringing down that first value. All right, so we're bringing down the 1. You will then multiply negative 6 times 1 to give you negative 6. Go ahead and combine those values. The 17 and the negative 6 will combine to give you 11. Then multiply negative 6 times 11 to give you negative 66. This will end up with a negative result. It'll end up with negative 12 from here. And then we'll be multiplying negative 6 times negative 12 to give you positive 72. This gives you a result of negative 3. And multiplying negative 6 times negative 3 gives you a positive 18, which means that this final result here will be 0. That's what's going on. And so your end result will be the following. Remember that our highest exponent, the highest degree in our initial problem was 4. So this degree of the polynomial that we were dividing into was 4. So you're going to subtract 1 from that highest degree, and you'll write down your result as the quotient as x to the third power because of that coefficient of 1 there, plus 11x squared minus 12x minus 3, and this is the quotient of the answer. What's going on, Vivian? How's it going there? So we're going to go ahead and finish up our result by putting it in a red box to contain it. That's right. We want to quarantine the answer. And there you have it. That is the result for problem number 25 using synthetic division. Now, of course, you could have used long division and got the same answer. However, oh yeah, with the red box. That's right, yo, dude. We got the red box in effect. However, our directions told us that we want to divide using synthetic division. That's right. Oh, Bina is in the house. You got it. Treacher says, okay, cool. He got it. Fantastic. Noah is like, yeah. What's going on, Chosen Creeper? Good to see you, Chosen Creeper. Good deal. All right, let's keep it moving, guys. That's right. We're just warming up. We're just warming up today. Absolutely. We have our next problem. Let me go ahead and show it to you guys so you can see it, put it in view. Go ahead and put that there in view there for you. We have problem number 26. It says to sketch the graph of each function. And if you know me by now, guys, you already know that I hate the directions, the word sketch. I don't believe in it. I don't want to leave my answer up to the discrepancy of or the judgment of an instructor, a teacher, a professor. No way. I'm going to give them the exact answer. That's what I'm going to do. All right. Because I don't want to leave my sketch up to how somebody's feeling that day. No, I don't. No. So I'm going to go ahead and give them the exact graph. It doesn't take too much. It doesn't take too much to give them the exact graph. Not at all. So what you want to realize is, first of all, the domain. All right. What's your values of x that you can use for this function, this square root function, matter of fact, is going to be depending on whether or not you have real results. Well, the answers to this problem, the results of this problem are only going to be real if your radicand is at least 0, because I can't take the square root of a negative number. No. In fact, the radicand, the values underneath this radical sign here, the square root sign, have to be at least 0. The lowest number it can be is 0 as far as the value of that x plus 4. So let's say that. We'll say that x plus 4 has to be greater than or equal to 0. And then by solving for this, we find that the lowest value that we can input into this function is negative 4. Yeah. See, negative 4 is the lowest value that we can plug into this. And what I'm going to do now is I'm going to use a little XY chart. I'm going to create some points that I can use to graph this exact function. That's exactly what I'm going to do. So I'm going to start out knowing that I'm going to use -4 as my lowest value. But then understanding that, I'm going to keep in mind that I'll be taking the square root of the result in this square root sign. Yeah, I haven't moved on, and I'm not even concerned about transformations, guys. I'm just showing you exactly how I would go about graphing this problem. So I'm going to start out with my first value of -4. We found this value by finding out what the domain is of this exact function here. Then, knowing that I'm going to be taking the square root of all of these values here, check it out. I'm going to use -3 as the next answer. That's what I'm going to do. I'm going to use -3. And then continuing on in that vein, I'm going to use the following number. Let's see here. I'm going to use, let's see, we got that. I'll be using, and we have, we have from Tony and Noah, we have a donation. So let's go ahead and hook up Tony and Noah with the donation. All right, so guys, as a reminder, you can always donate to Forbidden Tutoring using the super chat, or you can use the donation link within the description box, guys. So let's continue as I plug in the number 5. As I plug in the number 5 as the next value that I'll be using, and then in addition to that, we could use the number 12. All right, let's see how this works here. Okay, gotcha. So here is the deal. Lewis says it looks like a bullet coming from the right side. All right, well, we shall see. Treasure Ghost says, good job, Noah. And there it is. Danielle says, I don't even have to study anymore. I just love hanging around with Mr. Witt's live streams. I appreciate that, Danielle. Let's plug in -4 into our original function, guys. We have -4 plus 4. That gives you 0. The square root of 0 is 0. And then 0 minus 2 gives you a result of -2. So that's going to be the first point I can plot on this graph here. Continuing on, if I plug in -3, -3 plus 4 gives you a result of 1. The square root of 1 is 1, and 1 minus 2 gives me -1 here. Next up, we're plugging in the number 5. Plugging in 5, we have 5 plus 4, which is 9. The square root of 9 is 3, and then 3 minus 2 gives me +1 as a result. Oh, yes, it does. Next up, we'll have 12. 12 plus 4 gives you 16. Notice that the sums that I'm getting underneath the radical sign here, I want that radicand's value to end up being a square root, a perfect square rather, so that I can take the square root of it easily, and therefore I don't have to worry about graphing an irrational number for my value of x. I don't want that. For y for that matter. Okay, so I'm making sure that I end up with integers as the results of my points that I'm coming up with for the x and the y values here. So that's how I chose the following values of x, starting out by realizing what my domain could be. My domain had to be values that were greater than or equal to -4. That's why I chose -4 first, and then I chose additional values that would generate a perfect square underneath the square root sign. Absolutely. Continuing on, we know that 12 plus 4 is 16. The square root of 16 is 4, and then 4 minus 2 gives me a result of 2. So now I have 4 points that can be used to plot. There you go. Why did the screen minimize? So that I can show you guys the graph without going from there. All right, so is that better there? Let me go ahead and just get rid of it that way. All right. Is that better, Treasure Ghost? Because I was just minimizing the screen so that you could see me work while you could also see the chat there without it covering up the graph area. So that's what I was doing with that. So let me know if you if that was helpful or not helpful. All right. So keep me honest there. Okay, there you go. Treasure Ghost says you can remove the chat. Good deal. No problem. Continuing on, then, we have -4, -2 is our first point. So -4, -2 gives me a point right here. Then I have a point at -3, -1. Gives me a point here. I have 5, 1. I have a point right here. And then in addition to that, I'll have a point at 12, 2, which will be over here somewhere. Okay, so that means that as I graph this, and let's go ahead and use this color for our graph. Oh, that's ugly. Let's see what we can do here. Let's see what we can do here to make this. There we go. All right. It's going to do a little something like that, guys. All right. It's going to do a little something like that. You're seeing a new problem, Chosen Creeper? That's what it is, okay? I think I can make a better one, though. There's going to be a little curve action going on there. There we go. Something like that. There you go. But we have exact points going on here. I'm going to try it one more time. I'm going to make it cute one more time. Okay. I think that's it. There you go. Connect the dots, Dawson. That's right. So here we have our result. This is the sketch, aka the actual graph for our square root function. And that's how I take the problem. So what I'm presenting to the teacher is the exact graph. I don't have to worry about if this sketch is close enough to the actual graph because it is the actual graph and I have exact points to boot. I'm even telling the teacher and showing the instructor that I know the domain. That's what's up. Yes, right, Treasure Ghost. I am a total noob at connecting the dots. You got it. Especially on the fly. You know what I'm saying? I had to make it cute, man. What am I going to do here? What's going on, Aeon? How you doing? Good to see you today. All right, let's continue on, guys. We have a logarithmic problem. Yes, we do. That's right. Half of a bullet, says Lewis. In problem 27, we want to rewrite the equation in exponential form. They are giving us log of base 2 of 16 equals to 4. Yo, dude says this graph and stuff was on my last test, and I'm pretty sure I failed the graph because I couldn't sketch it. Oh, well, see, there you go, man. You got to check us out so you'll know how to do this stuff. Obina's in the house with the answer already. Let's see here. But hold on. So here's the deal. Here's the deal. Because Obina, I believe you already have the answer correct. We are going to use this conversion right here, guys. So anytime you have your equation written in logarithmic form, as I have here in green, this log of base b of x equals to y, all you have to do in order to convert it into exponential form is you take that base, raise it to the y value, and set it equal to x. That's it. What's going on, Anita? How you doing? Yeah, you're on it. Sasha's in the house. Will the questions you're going through today be useful for the SAT? Absolutely. That's right, yo, dude. Logarithms are a different way to write exponential equations, yo, dude. That's right. So we're able to translate between the different forms of equations, between logarithmic form and exponential form. So they're giving us a logarithmic equation and requesting for us to change this into exponential form. And this is how we're going to do it. Notice that my base of this logarithm is base 2. So I'll have 2 here. Matter of fact, let me go ahead and change to my black ink that I like here, guys. So we'll have base 2 raised to my y value. In this case, it's going to be to the 4th power. And this equals to 16. And it's over. That's it. It's over. And I'm going to red box this. So Obina is correct, as always. There it is, guys. Obina is correct with her exponential form of the logarithmic equation, log base 2 of 16 equals to 4. So the bottom line is, guys, if you need to know how to convert this, what you need is right here. That's right. You need that right there. You need that conversion between logarithmic form and exponential form, as you see right there. That's right. And Anita is saying she's finally able to watch it live. That's right, Anita. You're in the house with Mr. Witt and the crew right now. In other words, you're in the house with the witnesses. I had to steal it. I had to steal it from Simone. All right. She said everybody that watches Mr. Witt are witnesses. All right. And now let's move on to evaluating a logarithmic expression here, guys. Let's find out what this value is. They want us to evaluate log of base b of 1/3. That is what you want. Yo, dude says, you're so punny. Exactly, yo, dude. Good job with the punny. I love the pun and the bunny. You're cool, Anita. All right, so let's check it out. What's important in evaluating logarithms, guys, is if they are giving you a problem that you could do by hand, all right, then most of the time they're going to give you a value that you can find a common base between the base of the logarithm and the base of the value that's given to you here. So notice that we have 1/3 as the value. However, our base is 3. Well, the ideal situation is for you to be able to rewrite your value so that you're matching your base here. That's what you want. Okay, let me go ahead and wipe my screen real quick, guys. There you go. I'm getting excited over here. All right. So here's the deal. We're going to be rewriting this first and foremost as log base 3 of 3 to the negative first power. So what just happened there? I just went ahead and I moved up my base of 3, and that gave it a negative exponent there. So in other words, by shifting this base of 3 to the numerator, I was able to rewrite it, all right, by changing the sign on the exponent. That's right, Lewis. So that's going to be log base 3 of 3 to the negative first power is what I'm able to do. And then using the logarithmic properties, as Lewis has already done, what happens is when your value here matches the base of your logarithm, all of this cancels out so that you end up with your exponent, which is -1. And this is the answer. That's it. So this is all about being aware of your logarithmic properties there. That's absolutely correct. So all you're doing is finding out the value of the logarithmic expression. That's right, Obina. That solves the problem then. Absolutely. Yeah, it's it. That's it. And moving on, because we have things to show you guys for the Algebra 2 final exam review part 2 today. All right, so let's keep this thing moving. In problem number 29, once again, we're dealing with logarithms. This time we're dealing with natural logarithms. Yeah. And they want us to condense each expression, this expression, to a single logarithm. That's what they want you to do. So keep in mind that when you have the natural logarithm, that ln symbol here, that means that you are using a base of e. Oh, yeah. You're using the base, the constant e, as your base when you're dealing with that. In other words, when you see, I'm going to go ahead and put this in green for your notes here, guys, that when you have the natural log, all right, when you see that natural log there, it's equivalent to having a logarithm with base e. That's what that means. Let's move that over there. Okay. All nice and cute like. There you go. So when you see the natural log, you're dealing with logarithms that are in base e. Tell a friend. So here's what we're going to be doing next. We're going to be condensing this expression into a single logarithm. So keep in mind that using the power rule for logarithms, anytime you have a coefficient in front of your logarithm, your natural logarithm, you can make that into the exponent on your value there. So in other words, I can rewrite the first term as the natural log of x to the 5th power. It's equivalent that way. I can also say that this is going to be minus the natural log of y to the 4th power, so that I have it written this way. In addition to that, and Obina, I believe you are correct, ma'am, that at this point, because you have the subtraction between these logarithms with the same base, in other words, they're both based in e, all right, that you can go ahead and make this into a quotient. So this will be the natural log of x to the 5th power divided by y to the 4th power. And this is our answer right here, guys. This is it. Done and done. Good job, guys. Lewis is on fire with his answer. Obina is on fire with her answer. And we have it in a red box. That's exactly what's going on for problem number 29, guys, as we were condensing this expression to a single logarithm into a single natural log. Once again, that natural log, that ln there, that stands for the natural log based in e. All right, so these are interchangeable symbols. Treasure Ghost says, great job, Mr. Witt. Already. Let's move on to problem number 30 then, Treasure Ghost. TG. Let's get this thing moving. Here we have a problem where they want us to identify the vertical asymptotes and horizontal asymptotes of the rational function. That's what they want us to do. We have f of x equals to x squared plus x minus 2 divided by negative 4x squared plus 4. That's right. There you go. Chosen Creeper says, I'm just going to go ahead and be silent and watch full screen. You do what you have to do, Chosen Creeper. You do what you have to do, sir. In order to find out the vertical asymptotes, first of all, guys, I want us to rewrite this entire function fully factored, completely factored. Let's put it like that. Completely factor this. Let's go ahead and do that. we'll have f of x. In the numerator, looking for two factors of 2 that will subtract to give us 1, will be 2 and 1. We'll be able to factor this into x plus 2 times x minus 1. That is the factorization of the numerator. Then we want to factor the denominator. This will be a two-step process, right? Because you'll end up factoring out the negative 4. That gives you x squared minus 1. However, in your denominator there, that is a difference of squares. So that means that you can go ahead and continue factoring that difference of squares in the denominator to end up with x plus 2 times x minus 1 in the numerator all over negative 4 times x plus 1 times x minus 1. And notice that this expression is reducible. That is important. Okay, that's important because what that shows you is that there's actually a hole. Okay, there's actually a hole in this problem, and the hole is something that can be removed because you have identical factors in the numerator and the denominator. So go ahead and show that you'll be canceling out that x minus 1, that x minus 1 could be reduced there. It could be simplified. Okay, so keep that in mind. What's going on, Tamaya? How's it going? How's it going there? Good of you to join us today. So our simplified version of this function is going to be x plus 2 divided by negative 4 times x plus 1. And in order to figure out what your vertical asymptote is, you will only be setting those factors that contain your variable. Set that equal to 0 and solve for it in order to find it out. Notice that we already canceled out that x minus 1 because that is going to be a hole. It will not simultaneously count as a vertical asymptote. So you won't say that the factors that you'll be setting equal to 0 in order to solve for the vertical asymptote is going to be x plus 1 and x minus 1. Oh no, it won't be. It's only going to be the x plus 1 that you'll be setting equal to 0 for the vertical asymptote. So for this problem here, your vertical asymptote is going to be the result of setting x plus 1 equal to 0 and then solving for x. So this is going to be a vertical line that will be in the form of x equals negative 1. This is the equation of your only vertical asymptote that you have for this problem. You only have one vertical asymptote. You will ignore the factor for the x minus 1 because that is what is used to find a hole in the problem. It is not going to also be a vertical asymptote. It's either going to be one or the other. Either you're going to use it for the hole or you're going to use it for the vertical asymptote, but you're not going to use it for both. So that's why that's the only thing that we have as our vertical asymptote. And Obina, keep in mind that this has to be in the equation of a vertical line. So you have to write it as x equals negative 1. Just having the vertical asymptote say negative 1 is not enough. It has to be in the equation of a vertical line. So it has to be written as x equals negative 1. Now, as far as your horizontal asymptote is concerned, whether you're using the simplified version of the equation where we reduced it, or if you use the original function there, you should realize that the highest degree in the numerator and the highest degree in the denominator are equivalent to one another. They're the same. Okay, and as I told you in previous videos, guys, that your degree of the numerator and the denominator will be based on the highest exponent on your variable x once everything is multiplied out, if it isn't already. And so we'll take those highest terms and simplify it. In other words, we'll say that we'll have the variable y equal to x squared divided by negative 4x squared if you're using the original equation. The other terms that aren't the highest degree will not be used. They will be ignored because they'll be insignificant to our answer. And then you'll simplify this as your dude has done and end up with y equals negative 1/4. In other words, those x squareds canceled out, right? And so you end up with y equals negative 1/4, which is, what's going on, Angry Hermit, your result for your horizontal asymptote for this result here, for this answer, for this problem. And we will red box it. So what you have before you guys, the x equals negative 1 is the vertical asymptote for this rational function. The y equals negative 1/4 is the horizontal asymptote for this function here. And that is going to be the answer to this. Think too, how you doing? All right. You're welcome, sir. Good to see you there. All right. Good stuff. We are already red boxing our answers as we move forward, guys, in this part 2 of the Algebra 2 final exam review. And I want to remind you guys that you can feel free to set up a paid online tutorial with me, Mr. Witt, and Fort Bend Tutoring. All you got to do is go to tutormemath.net and check me out as far as setting up a one-on-one paid online tutorial with Mr. Witt. Amen, amen, guys. What was that last problem? That was problem number 30 already. Okay, well, we're keeping it moving in, guys. That's right. Michael Burns is in the house saying good morning to all. That's right. Yo, dude, is it only for Algebra 2? No. It is not only for Algebra 2. It's for whatever math class you need. The only math class I don't tutor for is statistics. And it's not because I can't tutor for statistics. It's because I don't like it. It's painful. I can't stand stats. So therefore, there'll be no tutorials for that. But we tutor for everything else. So whether you're in a calculus class, a finite mathematics class, geometry, trigonometry, all of those classes that we have on our YouTube channel, as well as on the website, that's what you can get one-on-one tutorial from me from. All right. Well, Mari, how's it going there? Good morning to you. Good morning to you. So just wanted to remind you guys that service is available to all those that are in need of it. So if you need some one-on-one attention, all right, that is not just enough for you to just check out some videos on YouTube or what have you. You can definitely have me one-on-one answering your specific questions. So it is a service that you can hire me for. All right, yo, dude says just finished Algebra 1, but going to geometry now, and I don't want to go. I understand. I don't have a love for geometry either, yo, dude, but I will tolerate it. Geometry is tolerated. Stats is not. Let's move on to problem number 31, guys. Here they want us to add, okay, these rational expressions, aka subtract them. All right. So we're going to be subtracting these two expressions together. All right, let's do that. Let's go ahead and change those directions to subtract because I don't want to confuse anybody. You could technically say that you're adding these two together because you could say that you're adding a positive and a negative together. So technically the add direction is just fine. But just for anybody stopping by, I don't want to stress anybody out today. I want you to fully understand what's going on. So we will change this to subtract. There you go. Good stuff. Yo, dude says, don't say stats. That's a bad word. I agree with you, yo, dude. Wamari says, I'm showing my niece how great you are at teaching and entertaining. I'm doing my best, Wamari. So tell your niece I said hello. Let's go ahead and start, guys, by finding the least common denominator for these two rational expressions because we're going to subtract them. Oh, yes, that's exactly what we're going to do. So we're going to start out by showing that these denominators could be factored into the following. We'll end up with x minus 4 times x plus 1 as the factorization of that quadratic trinomial. So if you need to be refreshed on factoring quadratic trinomials, check out the Factoring Quadratic Trinomials Part 1 video. All right, and if you got a little time there, go ahead and squeeze in part 2. There's 3 parts, but part 1 and part 2 will give you the gist of what you need to know for factoring quadratic trinomials. All right, I try to go ham on part 3 as I use the big numbers in that one and show you how to break down those quadratic trinomials that have large numbers involved. Oh, yes. Okay, the factorization of our second rational expression is going to be x minus 2 times x plus 1. Amen, amen. So when it comes to, what's going on, Dawson? I'm good with calculus and forgot that. Is that possible? Absolutely, Dawson, because the hardest part of calculus is your algebraic foundation. See, calculus has you bring in all of the things that you learned in algebra, and you could use all of those. You could use all of those properties and things that you learned there in one problem, potentially. Okay, so you can use everything. The hardest thing to do in calculus is recall all those mathematical foundational things that you learned in algebra. All right, so that's how a lot of people are stressed in calculus, is because they forget a lot of those things that they learned in algebra. So this is one of the things. Yeah, so definitely subtracting rational expressions and adding rational expressions is important for calculus and a lot of other math courses. All right, so the LCD, guys, let's get on that. So for this least common denominator here, we are going to do the following. I'm going to set up my problem here with my least common denominator, and it's going to be all of the different factors that I exposed by factoring those denominators at the beginning. In other words, I'll be needing an x minus 4 in my denominator. I'll need an x plus 1, and I'll also need an x minus 2. So these three factors, with their powers combined, I will end up with my least common denominator here. Yeah, that's what I have. So the least common denominator, once again, is this x minus 4 times, oh, that's an ugly 4. That's a hideous 4. We can't leave the house looking like that now, can we? All right, let's go ahead and fix this. Get this on and popping here. There you go. Angry Hermit says, just kidding. Here's the real one. All right. We'll see. We'll see. And now, yes, that is a hideous 4. Absolutely. We had to correct that. We'll be multiplying each numerator by their respective factors that were lacking in the original denominator. So what do I mean by that? Our original denominator for that first term was x minus 4 times x plus 1 when it was factored, right? Well, our LCD, our least common denominator, is x minus 4 times x plus 1 times x minus 2. And now we'll need to multiply the numerator by what we didn't have at first, which was that x minus 2 here. So what was missing in the second denominator? The second denominator, we had x minus 2 times x plus 1. Well, now they squeezed in this x minus 4 here. So we need to multiply the numerator, that original 3, by what we didn't have at first, which was that x minus 4. And notice that I have this little fancy 4 right here. See, that fancy 4 was a whole lot better than that ugly 4 that I had at first. Oh, yes. And now we'll be combining our numerators together. So when you combine your numerators, you'll show that you have 5 times the quantity of x minus 2 minus 3 times the quantity of x minus 4. All of that is going to be over your common denominator of x minus 4 times x plus 1 times x minus 2. So that's what we have right here. Amen, amen. And now, guys, there we go. Let's go ahead and fix this. So you can see it now. Now we got it. And now what we'll do is we'll distribute. So I'm going to get my arrows popping. Okay? I'm going to get my arrows popping here. And I believe I need to take this to the next page. I need to take this to another page, guys, because I'm running out of room here. I am running out of room. Can't have that. Let's go ahead and hook up another page for this. Let's insert a page. There we go. Insert a page here and continue. Check this out. Let's fix it. There we go. Better. All right, let's continue. Let's move this down a bit. We're getting things straightened out here, guys. We're going to fix this. Get this going. Let's continue. So now, let's have some fun. Wamari says, okay, I have to go and watch my teacher's videos so then I could come back and watch yours to understand what the heck she is talking about. Okay, Wamari. Well, good luck to you, sir. Thank you for stopping by. I appreciate that. And tell your niece I said, what it do? All right. So here we're going to be continuing. We have 5x, guys, in the numerator, minus 10, minus 3x, plus 12, all over the quantity x minus 4 times x plus 1 times x minus 2. All right. So this is what you guys getting. This is what you guys have in play. Combining your terms in the numerator, we'll have 5x minus 3x. That gives you 2x. Combining the negative 10 and the positive 12, we end up with a positive 2, right? Okay. All of this is going to be over that x minus 4 times the x plus 1 times the x minus 2. Amen, amen. From here, guys, continuing on with this, we can factor out a 2, right? Let's factor out a 2. So factoring out a 2 in the numerator, we'll have 2 times the quantity of x plus 1 all over that x minus 4 times the x plus 1 times the x minus 2, just like that. And what happens now? The x plus 1s will cancel out, just as Obina and Treasure Ghost have realized. And once those cancel out, guys, you'll end up with the following result. Let's go ahead and get everything in view. There we go. We'll end up with 2 over x minus 4 times x minus 2. And this is the result for this problem, ladies and gentlemen. Done and done. Treasure Ghost says he was right. Amen, amen. Good stuff. Well, we knew you were right already. Obina said so. There it is, guys. You have your result for this problem. Oh, yeah. So that was subtracting rational expressions. How fun was that? Right? So the toughest thing to get across in that problem, guys, is remembering or knowing how to find your least common denominator. All right. So when you're adding or subtracting, your rational expressions, you want to master finding the least common denominator. All right. Gotta have that. You gotta have it. In problem number 32, guys, it says to divide. Leave answers in simplest form. That's right. Michael Burns in the house. I'll be sure to set up one-on-one session with you during my next math exam. I look forward to it, Michael. I look forward to it, sir. You can go ahead and do just that, and I'll be there to help. So when you're dividing fractions, guys, because that's basically what we're doing with the rational expressions. Rational expression is just a fraction. You're going to be multiplying by the reciprocal, a.k.a. the flip of the second fraction, of the second rational expression. That's what you're going to be doing there. So we are going to factor and flip at the same time. Let's go ahead and see what that looks like, guys. We're going to factor and flip at the same time. All right. Let's see here. In the numerator of the first fraction, we can factor out an x to begin with, right? That'll leave me with x cubed minus 27. In the denominator, we have a difference of squares. That'll be x plus 5 times x minus 5. Times the reciprocal, the flip of the second fraction. All right. Michael says, as for now, I got to go. Got to study accounting again. Take care. Thank you, Mr. Whittington. My pleasure, Michael. Take care. Good luck to ya. All right. Thanks for stopping by today and sharing your time with us. Greatly appreciated. Guys, this quadratic trinomial here, that x squared plus 3x plus 9, it's not factorable. You can't factor that. Yeah, there aren't two factors of 9 that'll add to give you 3. So don't stress about it. If you can't factor it, you just can't factor it. Don't try to squeeze something out of something that's not going to give you any juice. All right? Like an orange or something. Like orange juice. You know, I love some orange juice, right? Okay. But today I have my water. Today is going to be a water day for me. So back to back with the water day. Let me go ahead and take a swig right now. That's right. Got my water working today. In the numerator of our first rational expression here, guys, that's a difference of cubes right here. That x cubed minus 27, we can factor this. So that's exactly what we will be. What we will be doing. What we will be doing. Got tongue tied there. Thank you. We're getting tongue tied. We have x times the factorization of the x cubed minus 27, guys, is going to be x minus 3 times x squared plus 3x plus 9. All right. If you need practice factoring a difference of cubes, guys, check out that video called Factoring a Difference of Cubes from me, Mr. Witt, in Fort Bend Tutoring. Check that out. Oh, that's an ugly plus sign. We got to fix it. We got to fix it for yo dude. Yo dude does not want to see an ugly plus sign. I know he doesn't. So I'm going to fix it. There we go. What you think about that, yo dude? Got it. Michael, take care. So here, guys, we're able to, now that we have everything factored and flipped, we are now going to be able to simplify before we multiply. And that's going to be my preference. So we can always simplify this vertically or diagonally, but never horizontally. You can't simplify going straight across. Nope. But you can cancel things out vertically or diagonally. So what we'll do here is I'm going to cancel out this x squared plus 3x plus 9 because it's ugly and it has to go. And remember, things are canceling out to 1. All right. Just like that. So the x plus 5s will also cancel out. Gone are they. They are gone. Simplified from the expression, from the answer. That's right. Then multiply straight across. So x times x minus 3 times 1 is just x times x minus 3. Then in the denominator, you're just left with the x minus 5. So this is our answer, guys. That's it. It's in a red box. It's over. There's nothing else for you now. It is all done. I got a red box around this. There you go. I don't know what kind of boxes you're putting around your answers, but mine's in red. And there it is. And now I'm on to problem number 33. Treasure Ghost says, and you were correct. Once again, Treasure Ghost is on fire today, guys. Are y'all keeping up with Treasure Ghost and his genius? Well, you better. That's why he's a moderator, because that boy's on fire. He don't play. He plays no games. Thumbs up to Chosen. Chosen Creeper says thumbs up, Treasure Ghost. All right. Hey, guys. In problem number 33. Treasure Ghost, no. Treasure Ghost, you're not bragging. You're just speaking the truth, sir. You're just being honest with people, and we love your honesty, sir. You need to be honest. That's all. That's all you're doing. 33, guys. Find the exact value of the logarithm. That's what we're doing here. We have the natural log of the fourth root of e cubed. That's exactly what we're going to do. We're going to simplify this. Remember that when we're dealing with natural logs, as I stated earlier in today's video, you have your logarithm is in base e. So that's good to know, right? So once again, let me go ahead and put that reminder for you that the natural log is equivalent to log in base e. There you go. There you go. There you go for your notes. That's right. And Obina has an answer already. Raul has an answer already. Let's go ahead and see what this answer is going to do, guys. I'm going to first of all rewrite this radical notation in exponential form. In other words, I can say that this is the natural log of e to the 3/4 power. Remember, when converting a radical into exponential notation, you'll have your base. In this case, my base is e underneath the radical sign there. And the exponent on that base goes in the numerator, and your index goes in the denominator. So this is a rational expression, a rational exponent rather, that we are using in our conversion from radical notation into exponential notation for that value. However, there is a rule, guys, as I told you before, that when your logarithm is equivalent to the base, or that value is equivalent to the base of your logarithm, you can simplify that and your answer is just the exponent. In other words, another way to write this, guys, was to show that this is going to be log of base e with our value of e to the 3/4 power. Well, in this case, guys, those will simplify to give you 3/4 as the answer. And that is why Obina is correct. That's right. And Raul is correct as well. Treasure Ghost is co-signing on that correct answer. And that is our answer for problem number 33. Not bad, guys, right? Not bad at all as we are moving forward in the final exam review. We have to solve, guys. We have an exponential equation for problem number 34. An exponential equation, which is 4 to the 1 minus x equals to 8. That's right. And one of the ideal setups for solving exponential equations is being able to identify a common base throughout your equation. Is to be able to identify a common base throughout your equation. All right. So here's the deal. 4 and 8 have a lot in common. We know this already. However, in order to rewrite this with a common base, we'll say that our common base that 4 and 8 have is the base of 2. See, I can rewrite it as 2 squared raised to the 1 minus x. I can show that that common base is 2. That 4 could be rewritten. Can I talk today? That 4 could be rewritten with a common base of 2. In other words, 2 to the second power is 4. I can do that same thing with the number 8. I can say that 8 is equivalent to 2 to the third power. You see there? Distributing the exponents on the left side, we now have 2 to the 2 minus 2x. And this is going to be set equal to 2 to the third power, you see. And now, because our bases are equivalent on either side of the equal sign, then that means that the exponents on those bases must also be equal to one another. In other words, this value of 2 minus 2x must equal to 3 in order to keep our equation equivalent. What's going on, Michael? How you doing? Thank you for stopping by today, Michael Bob. Now, let's go ahead and solve for this value of x. We're going to be subtracted 2 to both sides of the equal sign. We have negative 2x, which equals 1. We're going to divide both sides by negative 2. And now, guys, we have a result that is negative 1/2. Good job, everybody. Good job. All of you had those good answers. That's right. And Michael Bob says good with a smiley face. That's right. Michael coming in with the positivity. Thanks, Mike. Let's go ahead and move on to our next problem, guys. Our next problem is a piecewise function. That's right. We have a piecewise function for problem number 35, and we're going to be solving it. That's right. We have f of x equals to the absolute value. That's the absolute value, guys. The absolute value of x, with the condition that we will use this when x is less than negative 2. Obina says crazy composition. That's right. We got a function. We got the piecewise function going on. Treasure Ghost, don't get scared. We're with you. Somebody hold his hand. Somebody hold Treasure Ghost's hand. He's getting nervous over there. He shouldn't be nervous. It's going to be all right, TG. We're here with you. All right. Go ahead and hold Obina's hand there. She got you. It also says that the value of f of x will be 2 whenever x is greater than or equal to negative 2 or less than 2. Michael Bob says hold his hand. He's ready. He'll protect you. We also know that y will equal to 4 minus x whenever x is greater than or equal to 2, guys. So we have compositions in play along with our piecewise function. What's going on, Dan? That's right, Lewis. Piecewise indeed. Let's bring the peace. Let's look at problem number 1 here, guys. All right. Being as though they want us to find f of 1. Well, let's go ahead and find out what f of 1 is first. I know you got this, Michael. I know you got this. So what I'm going to do, guys, is I'm going to say that f of 1 is what value first. Let's find that out first, all right? So f of 1 means that you're going to use the value of 1 as your value of x, all right? And look at the conditions first, guys. Look at the conditions first. Your condition for when x is 1 would fall here. It says that when x is less than 2 and greater than or equal to negative 2, when it falls in line there, your result will be 2. So f of 1 is 2. All right. So this is going to be our in-between step, because we'll be using this value of 2 here to plug right back in to your function of f. So remember, they said to find out f of 1, right? Well, we just found out that f of 1's value is 2. So this becomes find f of 2. So finding the value of f of 2 means that we will be plugging in 2 right back into this piecewise function. And it states that whenever x is greater than or equal to 2, so we have a value of 2 now, right, to plug in, that we'll use this expression 4 minus x in order to solve it. So we'll be plugging in 2 into this 4 minus x expression and simplifying that to get an answer of 2. So the answer to part A is 2. That's what's up. So you start within the innermost brackets first, and you realize that they want you to find out what f of 1 is before you could do anything else. So we did that. We said that, hey, plugging in the value of x as 1 into this piecewise function, checking your conditions, it says that whenever x is less than 2 and greater than or equal to negative 2, we should know that the y value will be 2. That's how we got that initial 2 here. Okay. Then we plugged that, we substituted that back into our problem, and we had to find f of 2. So that means that now the x value that we're using is 2. So going back to the piecewise functions conditions, it says that when the x value is 2, notice that it says at this last step that x has to be greater than or equal to 2 in order for you to use the expression 4 minus x to find the value of y. We did that. You plug in that 2, simplify it to get your answer, which happens to be 2. Amen, amen. Michael Bob says, are you guys all from America? No, we're not, Michael. We're all over the globe. We just had Michael Burns that just left. He was from South Africa. All right. And we got people from all over, sir. People from all over. However, Michael Bob's from Australia. Awesome. Obina's from America. Mr. Witt, who's talking to you right now, is from America. All right. And Dan is from Canada, so we got people from everywhere. Let's go ahead and get that chat up here so we can show the love to everybody. Maple syrup for breakfast. Amen. Chosen Creepers from the Philippines in the house. Let's check out Part B, guys. Part B. Okay. Well, when we're dealing with Part B, we have our problem, which is going to be f of negative 4, guys. All right, so that means that we'll be figuring out what f of negative 4 is first. So that means that your value of x that you'll plug into the piecewise function is negative 4. Okay? And so plugging in negative 4 into your original piecewise function. All right, let me bring that down a little bit. All right, what's going on, Derek? I knight thee, Sir Wit. Good deal. I appreciate that. But use 2 T's on my wit, Derek. All right. Go ahead and get my knighthood written out correctly. Okay. Before you make it official. When plugging in the value of negative 4 into our piecewise function, that means we'll be utilizing the first condition where it says that if x is less than negative 2, you'll take the absolute value of that. So that means we'll be taking the absolute value of negative 4. All right, let me fix this. All right, there we go. Make it a little prettier. The absolute value of negative 4 is going to be 4. There we go. WHITT, absolutely. Give me 2 T's in that. I appreciate that. So from here, you're plugging in 4 back into the original problem here. Let's check that out. So we'll have now, we'll have f of 4. Well, that value of 4 means that we're once again going to use that not the second condition, but the last condition, the third condition, where it says if fx is greater than or equal to 2, that we'll use 4 minus x. So in this case, we're going to say 4 minus 4 and get an answer that is 0. Uh-oh, went too far, guys. There we go. Just trying to grab my red pen there so we can red box it. All right. Dan wants us to blue box it, guys. You want a blue box? All right, I'll go ahead and give you a blue box, Dan. There you go. Okay, we keep this up. We'll have our red, white, and blue for America. There you go. So the next box is gonna be in white, so I can have all 3 of my colors. All right, good stuff, guys. Y'all don't mind me being a little patriotic today, do you? All right, let's check out this last problem here. Let's check it out. We have Part C. Let's see if we can get this going. With Part C, guys, we're going to be finding out f of 7. All right, appreciate that, Michael. So we're going to start out by plugging in 7 into the piecewise function. All right, so let's see how that works out. Plugging in 7 into the piecewise function, and we'll keep track of it right here. We'll say that the value for f of 7 would be the result of 4 minus 7. How do I know that? Because the x value is 7 that we're going to start out with. You're going to start out with the innermost parentheses as far as the conditions are concerned. So start out with that value of 7 first, guys. Then, according to that last condition, if x is greater than or equal to 2, you'll use the expression 4 minus x in order to find out that y value. So we'll have 4 minus 7, which gives us negative 3. Okay? So this initial value is negative 3. So that means that now we'll be finding out, okay, what f of negative 3 is. Okay? So that means that now with that negative 3 value, you're going to use the first condition. So the absolute value of negative 3, because that's what you'll be doing next, is taking the absolute value of this result that we got here. The absolute value of negative 3 is positive 3. So we went from here, from that negative 3, to taking the absolute value of negative 3, to now using 3, positive 3, as your last value of x to plug into. Okay? So now plugging in 3, no, Joseph Kruger, it's not 1x1. It's the absolute value of x. That's what that is for that first one. You guys are crazy. So now plugging in positive 3, we'll be using that last condition there. And it will have 4 minus 3 in this case to give us a result of 1. So part C, guys, part C is 1 as our final answer here. Done and done. Oh, I'm sorry. I said that the last one is going to be in white. White boxing it. There it is. Red, white, and blue boxed. There you go. How you like that, Dan? Good stuff. Tony says Noah would love to stay, but he has to work to do. Goodbye for now. Take care, Tony and Noah. Thank you for stopping by. I appreciate you. All right, good deal. White boxing it. There you go. There you go. See, we have a color for everybody today. We're so inclusive here at Fort Bend Tutoring. Dan says this is the most math. This is the most fun math ever. Exactly. That's right. We definitely have fun when we're doing our math. Let me go ahead and move on to the black pen now. Guys, we're solving this radical equation. We have the square roots on both sides of the equal sign. Oh, yeah, they think they're going to trick us up today, but we're ready for them. We're ready, okay? No harms going on here. You are going to be well protected. All right. You're going to be well protected by Mr. Witt. We're going to start by squaring both sides. That's what we're going to do because we need to get rid of these square root signs. So keep in mind, guys, that you could have extraneous solutions here because there are domain restrictions for both of these radicals. So you could take your time at the beginning finding out what your domain restrictions are as far as what the domain can be, because you can't take the square root of a negative value, all right, and not with real numbers at least. So therefore, you could start out by locating finding out what the domain of the original equation is. You could do that. However, I would prefer just to solve the problem and test my potential solutions into the original equation to identify any extraneous solutions. All right. So that's what I'm going to do for this particular problem. So I'm going to start out by squaring both sides. That's what I'm going to do. That's what I'm going to do. That's what I'm going to do. I'm going to square both sides. And when you square the right side, guys, keep in mind that this will become a binomial squared, that you do not square each individual term. You'll get the answer wrong if you do that. Okay, so make sure that you will square both sides, meaning on the right side it becomes a binomial squared, and also, guys, make sure that you're checking your results to see if you have any extraneous solutions. So on the left side, the square root and the square will cancel out. We can bring down that 2x plus 5. On the right side, we'll be expanding the square root of x plus 2 plus 1 times the square root of x plus 2 plus 1. All right, so notice that I expanded that right side because we're going to end up having to full this out, and aka we're going to need to use the distributive property and get our arrows popping as we distribute those two binomials together. So I'll end up with the 2x plus 5 here. The square root of x plus 2 times the square root of x plus 2 gives me x plus 2. Then the square root of x plus 2 plus 1 is square root of x plus 2. 1 times the square root of x plus 2 is another square root of x plus 2. And then 1 times 1, well, of course, is 1. That's what we have. And now we'll be combining our like terms, guys. That's exactly what we'll be doing here. We'll be bringing down the 2x plus 5. This equals to x plus 3 plus 2 times the square root of x plus 2. So that was me combining my like terms on the right side of the equal sign. At this point, I want to isolate the new radical that I have here. Notice that I was able to get rid of one radical sign by squaring both sides, but I'm still left with another one right here. So we have to go ahead and start by isolating that term in hopes of getting rid of that square root sign as well. So I'll do the following at this step. I'm going to subtract x to both sides, and I'm also going to subtract 3 to both sides. That's what I'm going to do here. All right? That's what I'm going to do. Okay, so we got people chiming in with their answers. All right, let's see if I can match you guys. We have 2x minus x is going to be x. We got 5 minus 3. That gives me a positive 2. The x is canceled out. 3 is canceled out. I'm going to bring down 2 times the square root of x plus 2. Now, guys, I could divide the entire solution. I could divide the entire equation by 2. I could do that. Okay. However, I'm not going to divide everything by 2 now, because I would end up with fractions over here on the left side, and I don't want to deal with those fractions. So instead, I'm going to leave that 2 where it is, and I'm going to just go ahead and square both sides as it stands right now. So I'll be squaring the left side. Once again, this becomes a binomial squared. On the right side, I'll have 2 times the square root of x plus 2. That'll be squared, and I'll be expanding the left side. So this becomes x plus 2 times x plus 2, and on the right side, when you square the 2 squared, of course, is 4, and that'll leave us with the quantity x plus 2 once we square that square root sign. All right, so that's what we have at this point. Let's go ahead and grab this, guys, and take this to a new page so we can continue with this problem. All right, go ahead and add a page up in here. Oh, I was already ready for it. Good. Okay, I already knew that I was going to need an additional page. Good for me. So we already had that page ready. So now, continuing on, let's go ahead and bring this in view, guys. There we go. Let's go ahead and get our arrows popping on the left and the right side of the equal sign, for that matter. So with our arrows popping, we have x times x gives us x squared. We got x times 2 is 2x. 2 times x is 2x. 2 times 2 is 4, of course. Distribute the 4 on the right side. 4 times x gives you 4x, and then 4 times 2 is 8. And we now have a quadratic equation, guys. Yes, we do. Let's go ahead and set this equal to 0, combining our like terms on the left side as well. We'll have x squared plus 4x plus 4 equals to 4x plus 8. We'll be subtracting 4x to both sides of the equal sign. Oh, yes, you will. Go ahead and subtract that 8 to both sides while you're at it. We end up with x squared minus 4 equal to 0. This means that with this difference of squares here, that's right, Jamila, we're going to get these arrows popping here. With this difference of squares that we have right here, guys, we can go ahead and factor this using the zero factor property. We have x plus 2 times x minus 2 equal to 0, so that your potential answers here, once you set each factor equal to 0 and solve for it, your potential answers here, guys, is going to be either. Let me get my words together. We have either -2 or +2. But remember, this has to work in the original problem. So let's check out what happens with the -2 first. Plugging in -2, guys. Let's see what's up. What's going on, Kaylee? How you doing, girl? Good to see you. Plugging in +2, or the -2 first, we'll have 2 times -2 is -4. And -4 plus 5 is 1, and the square root of 1 is 1. All right, so let's see there. We got a 1 right there. On the right side, we would have -2 plus 2. That gives you 0. The square root of 0 is 0, and 0 plus 1 is 1. Guys, the -2 works. The -2 works. That's right. So therefore, we know so far that -2 is a good solution. Let's check out what happens. I missed you too, Kaylee. Where you been all my life, girl? Wrong with you? Taking a vacation from Mr. Witt. Shame on you, Kaylee. I'm glad you're back now. Good stuff. So here we're going to be plugging in +2 now, guys. We have 2 times 2, which is 4. 4 plus 5 is 9. The square root of 9 is 3. So this value is now 3 up here. Let's see. Uh-oh. It's now 3, and let's see if we can match that on the right side. Plugging in 2, we have 2 plus 2 is 4. The square root of 4 is 2. And guys, 2 plus 1 does equal to 3. So therefore, both of these answers are good solutions. So your solution set for this problem, number 36, is going to be -2. Oh, that's supposed to be a brace, guys. You know I cannot draw a brace. There we go. That's a better brace. We have -2 and 2 for our answers. Oh, take your time, Mr. Witt. Take your time, Mr. Witt. Oh, my God. Okay, that's going to have to do, guys. That's going to have to do. That's going to have to do. We have our solution for problem number 36. There we go. We have our solution for problem number 36. Done and done. That's right. What you think about that? Good stuff, guys. We have -2 and 2 for the answer. So yeah, that's what we got. And the chat is on fire with the math that we got going on today, guys. We have a math party going on today, and I had an opportunity, guys, to get my arrows popping. Yes, I did. I don't need a laugh track. I don't need a laugh track TG. All right. I got my laugh track right here, up in your ear. How about that? Jamila over there laughing for me. Okay. And Kaylee's sure enough laughing. That's what's up. Hey, guys, so I want to remind you guys to subscribe to Fort Bend Tutoring. I would greatly appreciate that. Go ahead and share it with your friends and family, especially those people that you hate, the people that you can't stand. You know they don't like doing math. Go ahead and throw some math in their face and say, here's a channel where I could just make your hate even more. Go ahead and share some math with the people that you love and hate. There you go. Stop being stingy, keeping this math all to yourself. Why are you so stingy with it? What's your problem? You have a problem. Let me solve it. That's what we do here at Fort Bend Tutoring. We solve problems. Go ahead and share that information with everybody. Let them know. All right? Subscribe to the YouTube channel. Click that bell icon so you can be notified when we have new content. That's right. And you may even get a chance to hang out with Kaylee. That's right, if you catch us with a live stream. How about that? Can't hang out with Kaylee if you don't catch us live. How about that? Now, catch me outside. Catch me outside with that math. All right, so Treasure Ghost says this is a channel of love, not hate. Sure it is. But we be hating on these problems, though, because we kill the math problems. All right, so there's a little. Kaylee says, cash me on FBT. Already. Chosen Creeper says, how about that? Hey, guys. That's what's up, Dan. We don't play around here. Number 37, guys. Number 37. Y'all keep the party going now. Problem number 37 says, simplify the expression by rationalizing the denominator. All right. So what we're going to do here when we are simplifying this denominator, when we're simplifying this expression by rationalizing it, we're getting rid of all of the square roots in the denominator here. We'll be multiplying by what's called the conjugate. That's what's up. All right. That's right. So Jamila says it's absolutely a love-hate relationship with math. All right. See, Mr. Witt is part of that love part. Okay. And when you're not with Mr. Witt, that's part of that hate part. So stick with me. Stick with me on the love side. There you go. We'll be multiplying the numerator and the denominator, guys, by 2 minus the square root of 5. This is the conjugate. All right. So it is the conjugate that we use to rationalize the denominator in this case. That's right. Rationalizing the denominator with the conjugate. And that means that we'll be multiplying this out, guys. That's right. So you can consider the denominator two binomials that will be multiplied. That's right. I will be getting those arrows popping as I work this problem out. We're going to get those arrows popping, up in this piece. All right. How about that? So now we have 3 times 2, that gives us 6. We have 3 times -5, that gives me -3 times the square root of 5, guys. In the denominator, we have 2 times 2, which is 4. We have 2 times -square root of 5, gives you -2 times the square root of 5. We also have square root of 5 times 2, that gives you a positive 2 times the square root of 5. And we also have the square root of 5 times negative square root of 5, which just gives you -5 as a result. Let's go ahead and extend that fraction bar there. All right, let's go ahead and make that out. Are we gonna? No, you can't. You're gonna mess that up. There you go. Stop messing it up. Stop messing it up, Mr. Witt. There we go. Jamila says I don't like statistics too. I don't like statistics too because I can't say the word statistics. That's why I don't like it. All right, it sucks. There you go. Treasure Ghost says conjugate the verb be. I be on number 37. How about that, Treasure Ghost? Conjugate that. So now in the denominator, our additive inverses will cancel out. And we have 6 minus 3 times square root of 5 divided by 4 minus 5, which is -1. Dividing each term by -1, guys. Dividing each term by -1 changes the signs. It does change the signs here. So we'll end up with -6 plus 3 times the square root of 5. All right. I don't like the way that looked. Let's fix this. All right. Is that better? Is that better with the chat out the way? Let's get that chat out the way. There we go. So we're going to red box this, guys. What you got? What you got? I got -6 plus 3 times the square root of 5. Are you with me? All right, good deal. Good deal. Treasure Ghost hitting us up with all the different languages over there. What's going on with that, Treasure Ghost? What's going on with that? How about that? We have problem number 38, guys. We have problem number 38. Let's check this out here. Oh, that's in the way. I'm going to have to remove the chat, guys. I'm going to have to remove the chat for this one for right now. It says, use the Scardiest rule of signs to determine the possible number of positive, negative, and complex zeros. That's what we're going to do. We're going to do a PNI chart, guys. A PNI chart. But the first thing I want to show you is that part of this PNI process, and the PNI, guys, stands for positive, negative, and imaginary numbers as far as their zeros are concerned. We need to find out what R of negative X is in this process, okay? So that means that all of the X's will be replaced with negative X, and we'll simplify this, okay? So we're going to find out what we're given the R of X, right? We're going to be finding out R of negative X right now, okay? Because we'll need this for this process. So this helps you determine the type of answers you're going to get in a polynomial equation here. And it's called the Scardiest rule of signs. It's pretty cool, guys. It is pretty cool. I will admit that is one of the cool things about math that I like. Simplifying this term, this first term here, you'll end up, because that negative base is raised to an odd exponent, you'll get a negative result from that. And then that negative times that negative gives you a positive 2x to the 5th power. With the second term, the negative x raised to an even exponent will give you a positive result. So this will remain 4x to the 4th power. All right. Then the negative x being squared gives you a positive result. That positive times the negative gives you negative 2x squared plus 5. All right. So now we're ready to party with Mr. Witt. There it is. Good stuff. Good stuff. Michael says, I speak Arabic and English. Treasure Ghost says, I'm also learning French at school. Hassan is in the house. O levels, maybe. All right, we're about to find out. Okay. So you guys over there are just showing off about how many languages you know. Good for you guys. Good for you guys. I know about the language of mathematics. How about that? How about that? I know that language. That's right, Jamila. Math is a universal language. I know that language. How about that? I'm still on that last joke, guys. Hey, What you want to do with the Scardiest rule of signs is that to find any potential positive zeros, you want to count the sign changes in your original function. So notice that we started out with a negative. We then went to a positive. From that positive, we go to a negative. From that negative, we went to a positive. So there were three sign changes in the original function. And what you do, guys, is you will count down by twos from your potential zeros. In other words, for the positive zeros, I could have 3 or 1 positive zeros. I could have 3 or 1 positive zeros. So you count down by twos. Now, when you're counting down by twos, you don't ever go to a negative. Okay? So because I started at 3 sign changes, you count down by 2, so you'll get 1, but you don't count by 2 again. You don't count down by 2 again because that would end up giving you -1. You can't have -1 zeros. All right? So that's not a possibility. So you stay in the positive or with a 0 as far as your potential zeros are for your positive numbers that you could have as a 0 in the equation. That's what they're referring to. For your negative sign changes, you're going to be looking at when we plugged in that -x. What sign changes do we have here? We only have one sign change. Why? Because the first term is positive, the second term is positive, then you have a sign change to become a negative, and then you have another sign change here, right? Okay, so that means, guys, that I'm going to need to show this P&I chart. I'm going to need some room for this because we'll have a lot of potential situations. Let's go ahead and bring it up here. Or over here. Yeah, all right. Let me hook this up real quick, guys. Let me hook this up real quick because I need to make some room for this P&I chart. Okay, I need to make some room for the P&I chart real quick. Let me hook it up. Okay, so I'm going to slide that over a little bit. Okay, slide it up and over. Okay. Better. And then let's bring this down here. Okay. No. Let's bring this down here. Okay. A little better? Oh my goodness. All right, guys. Let's see if we can work with that. Let's see if this works. See if I can work with this. Okay, here we go. Now, the deal is this. We said that our possible negative values, okay, are going to be 2 sign changes or no sign changes or no negative values, no negative zeros, okay, because we said that we're going to count down by 2. But we're going to have to repeat this because you could also have 1 positive with 2 negatives, or you could have 3 positives with 0 negatives. All right. However, this table has to equal, each row has to equal to the highest number, the highest degree in your polynomial. And this highest degree is 5, guys. It is 5. So but look at our first row. We have 3 plus 2, which is already 5, right? So that means that in this scenario, you would end up with 0 imaginary zeros. 0 imaginary complex zeros here. However, with this second scenario where you have 1 positive real zero, 0 negative real zeros, you would end up with 4 imaginary zeros. Notice that it still has an equal to 5. So 1 plus 0 plus the 4, it equals to 5. Then we have 1 plus 2, which is going to give you the 3. That leaves you with 2 imaginary zeros in this scenario. And then finally, in the last row, you'll have 3 positive zeros, 0 negative zeros, and 2 imaginary zeros. So this is your completed P&I chart. Dan says, if they're imaginary, can't we just imagine that they don't exist? Maybe. Maybe. All right. So that's how you do it. Hassan says, mind blown. There you go. Interesting. So yeah, so this helps you determine what type of solutions you can get out of any equation using the Scardiest rule of signs. Absolutely. Well, Dan, the way it works is you could have real friends in life and imaginary friends in life, but if you want to meet more real friends, don't tell them about your imaginary friends, at least not at first. And so this is what this is doing now. This is why this first row has all real numbers in it. We don't want to talk about the imaginary numbers until after we get to know one another better. Yeah. That was problem number 38. I'm moving on. I am so moving on, guys. That was the Scardiest rule of signs. Yeah. That's what we had there. We are asked to simplify. We have x to the m times x to the 3m plus 2 times x to the negative third power. That's what we have, guys. Oh, yeah. And so our base is x. And all we have to do is add all the exponents together. So this exponent will be the result of m plus 3m plus 2 minus 3. So simplifying this, you'll have m. I hated that. Let's fix it because I think I hate that. There you go. Better. So this gives us x to the 4m minus 1. And this is our answer. And we boxed it. 39 didn't even see us coming. 39 didn't even see us coming. Well, if you guys got to go nighty-night, I understand. Good night. Take care. And thank you for spending some time with us today. I appreciate that, guys. Mike Bob in house. You got to sleep. I understand. Chosen Creeper. Got to sleep. I understand. Take care, guys. Thank you for spending time in the chat today with Fort Bend Tutoring and the crew. Treasure Ghost says, with parentheses, absolutely. See ya. So we can go ahead and make sure that we're defining this exponent better. All right, especially if you're not able to clearly show that that's an exponent. So we have x to the 4m minus 1. I got the parentheses right here, Obina. There you go. All right. Mine wasn't necessary because it was clearly the exponent on mine. So you didn't have to have it as an exponent on mine. But there you go. Treasure goes over here threatening people. Don't threaten Treasure. Don't threaten Chosen Creeper. Don't do that. Hassan says, you said this is similar to indices. They can be if they're rational exponents, Hassan. Yeah, you end up with indices when you have a denominator within the exponent. So when you talk about rational exponents, then you can have then that is the same as indices. But not in this particular problem. Unless the value of m gives us a denominator. There you go. So that's problem number 39, guys. Keeping it moving. There you go. Problem number 40, guys. It says find the focus of the parabola. Now, when you're dealing with the conic sections in this class, then that means that you'll be introduced to this information here. That's right. Where you'll have the equation written in this format here. Ugly, right? And your vertex is always HK. Your focus is going to be H plus AK. And then the directrix is going to be this. So what they're referring to is like in a vertical parabola, guys. Let me go ahead and show this to you in purple. That let's say that you have your parabola there. Okay. The focus is going to be a value right here. It's going to be a point like sitting right there. And then the directrix would be a horizontal line right underneath it in that scenario. So as far as a sketch is concerned, because this is clearly one, that the equation is going to be a parabola. The vertex would be the minimum value of that parabola in this case. The focus is this point right here, okay, right above the vertex. And then equidistant from the vertex is going to be the directrix, a horizontal line beneath the parabola. So these are all things that are used when you're referring to conic sections when dealing with parabolas, all of which I cannot stand. However, this is to answer the question. Since we have the focus of this parabola shown that if you have this y minus k squared equals to 4a times the quantity of x minus h, and we want to identify the focus, we need to first of all recognize that in this scenario, our vertex, okay, the current vertex, let's go ahead and write that in black. Our current vertex here is going to be 0, 0. Because notice that this could be written as y minus 0 squared equals to 32 times x minus 0. All right. So if you're going to look at apples to apples, you can rewrite the equation to represent this standard form here. Okay. So that means that we have a vertex of 0, 0, knowing that this is our h value. This is our k. This is our h value here. I'm sorry. And this is our k value there. Therefore, for solving for the focus, you need to find out what the a value is. So we can set up an equation that reads that 4a from our standard form here must be equivalent to 32. And then dividing both sides by 4, you'll find out that your a equals to 8. Well, what do they say about the focus? They said that in this situation that your focus is going to be 0 plus 8, comma 0. All right. So therefore, Obina, you are correct. The focus is 8, 0. Done and done. Very good, Lewis. Very good, Obina. You are correct. Good job, Mr. Diaz. Let's go ahead and red box this, guys. Red boxing it. Done and done for problem number 40, guys. For problem number 40. Oh, yeah. That's what's up. We moving on. Cannot stand finding the focus in directrix. Can't stand it. All right. But I'm moving on now to something I do like, which is multiplying rational expressions. 41, guys. Multiply the expression, simplify the result. When I have a problem like this, guys, I go ahead and I attack the coefficients first. The coefficients are in trouble right now because I'm about to kill them. Then, as far as the variables and their exponents are concerned, I just go ahead and multiply straight across at first. So let me show you exactly what I'm talking about here. For instance, I know that 3 goes to itself once, 3 goes into 6 twice. We also have 2 going into itself once, 2 goes into 20 10 times, guys. 5 goes into 10 twice, 5 goes into 15 3 times. So that's what I mean by simplifying the coefficients first. That's what I prefer to do. Then I multiply straight across. So I'll end up with 3 d to the 4th power, e to the 7th power, f squared, all over 2 d to the 9th power, that's supposed to be a d, d to the 9th power, e to the 3rd power, f. Just like that. That's what I got. Then I know that wherever the largest exponent is in the numerator and the denominator for each of my variables, that's where the variable will remain. In other words, the variable will remain, will stay wherever the largest exponent is when you have all positive exponents. So let me set this up. I have 3 in the numerator, 2 in the denominator. The d variable will remain in the denominator because that's where the highest exponent is. And then to find out the exponent on that variable, you simply subtract the exponents. So we'll have 9 minus 4. That gives me d to the 5th power. That's what we got. Okay. Then as far as your e is concerned, the variable e will remain in the numerator. Subtract those exponents. 7 minus 3 gives you e to the 4th power. Then as far as your variable f is concerned, you'll have 2 minus the 1 to give me f to the 1st power in the numerator. Therefore, we have our answer right here in a red box. Obina says, well, that's where my 6th grade math teacher's words come in. Is that right? All right, well, there it is. There it is. Treasure Ghost says parabola always sounded like a disease for me. It does, doesn't it? Like Ebola. Exactly. TG says that he forgot the f variable. No problem. No problem. Go ahead and make that correction. What about your e variable, though? Did you forget the e, Treasure Ghost? Oh, I see what you said. All right, so Treasure Ghost says 3e to the 4th. I see it now. Over 2d to the d to the 5th power. You forgot the f. I see it. All right. Treasure Creeper says, too bad I graduated with the last math lesson was integers. Integers. Okay, interesting. So hopefully we can bring you up to speed, Chosen Creeper. Zenobia, will we always keep reducing the coefficients? It depends on the problem, Zenobia. It does. If you could continue reducing, it depends on the numbers and how they work together. All right. So will it always be the case? No. But you should always reduce the coefficients if you can. All right. But it won't be every single time that you'll be able to keep reducing as I did. All right. So it depends on the numbers that they give you. Great question, Zenobia. That concludes problem number 41, guys. Let's move on to problem number 42. As we have 1/16 equals to 64 raised to the 3x plus 5. Good job, Zenobia. Glad that you figured that out. Now, we want to look at having a like base in this exponential equation, guys. And what I see in both the 1/16 and the 64 is a base of 2. That's what I see. So I'm going to rewrite this, guys, as 1 over 2 to the 4th power. And I'll have 2 to the 6th power raised to the 3x plus 5. Got to have those parentheses in there for Obina, or she'll yell at me. All right. So we have 1 over 2 to the 4th power equals to 64, which is now rewritten as 2 to the 6th power times the quantity of 3x plus 5. All right. Well, I guess you guys are calling indices exponents, Hassan, because we usually only say that it's an index if it's like a root of a problem. And I guess you could have a root of a problem depending on the value of x, but it all depends. So we just call these exponents. But if it's going to be like, let's say, for instance, let's go ahead and put this in green. Let's say, for instance, that it's going to be a raised to the 3/4 power. We would say that the index in this expression would be the number 4, Hassan, the way we say it. So we would say this is going to be equivalent to the 4th root of a to the 3rd power. Therefore, the index of this is 4. So that's how we say it. That's how we use the terminology here in America. All right, that we would say that the index of this expression would be 4, whereas the exponent on the base of a is 3. So if you just have something just simply raised a superscript in general, we call that an exponent, although it could be an index depending on if it's in the denominator of the rational exponent, if that makes sense. All right, but good pointing that out, though. All right, let's continue on. Over here, back to our problem, guys. I'm going to now shift this base of 2 to the numerator. So I'll end up with 2 to the negative 4th power. Then I'll have this raised to the 2 to the 18x plus 30, all right, as my exponent. All right, indice, as Hassan would say. What's going on, Chris? How you doing there? There it is. Good. Let's continue on then. Because we have a common base, guys, on either side of the equal sign, we can make an equation that reads negative 4 must be equivalent to 18x plus 30, and then solve from there. So we're going to subtract 30 to both sides of the equal sign for starters. That's exactly what we'll be doing here. Oh, yes. Getting this on and popping. So you'll end up with negative 34 equals to 18x. You're going to then divide both sides by 18, guys, and then simplify to find that your value of x is equivalent to negative 17/9. And this is what I have for my answer, just like TG does. Treasure Ghost in the house with the answer. We will red box it. That's right. Just Chris says that we got it popping. Okay. Well, the only arrow that I had popping in this problem, Chris, was this arrow right here. So you can say when I shifted that base to the numerator, I had my arrows popping. That's right, Chris. As always, appreciate that, Chris, with the arrows popping reference. And as a reminder, guys, I just want to remind you guys that you can always set up a paid online tutorial with me, Mr. Witt. And for Ben Tutoring, just going to our website, which is tutormemath.net, to set up a paid one-on-one tutorial with me, Mr. Witt, and I will assist you as best that I can with your assignments and what have you, and your understanding of mathematics. Amen. Also, please subscribe to the YouTube channel, guys, as that helps us grow and helps us keeps us motivated to bring you more free content from For Ben Tutoring. In addition, you can use that super chat button on the bottom there to donate to For Ben Tutoring, as well as the description box has a donation link for you to assist us in our growth and also helps us pay the bills to keep this free content going. All right, because the internet ain't free. How about that? Let's move on to our next problem, guys. I'm not done with you just yet. I got problem number 43 coming your way, guys. Problem number 43. Let's talk about it. Here they want us to simplify. And in simplifying this problem, I'm going to start out by simplifying the coefficients first. Zenobia, I'm going to do that first, okay? So we have the 4 being reduced by 2, so that'll be 2. 2 goes into 18 9 times. So I'm going to bring down this 9e to the 18th power all over 2e to the 13th power. However, as I told you earlier, the variable, in this case, the e here, the e variable, will remain wherever the highest exponent is. So it's going to remain, the e will remain in the numerator. So you'll have 9e to the 5th power as you take the difference of 18 and 13 all over 2, and this is our answer right here, which could also be written as 9/2 e to the 5th power. So that's another way to write it as well. All right. And I probably would write it better if it wasn't that slant right there. So let's just go ahead and hook this up. Let's say that we have 9/2 then e to the 5th power. Better looking, right? Let's put a box around this. A red box. There you go. That's what we got. Done and done. Obina has the correct answer. Way to go, Obina, with your correct answer. Very good. That was problem number 43. We're moving on, guys. We're moving on. So here, we are asked to write the equation of the parabola in standard form. Now, notice in this problem that the highest exponent, the highest degreed term, is x. X is to the 2nd power. So therefore, we are looking at the standard equation being in this form right here. Let me go ahead and remove the chat so you can see that our standard equation would be in this format right here. So if anything, you want to set up a situation where you're isolating the first 2 terms over here so that we can complete the square. So I'll be adding 12y to both sides of the equation for starters. I'm going to also add 51 to both sides. So let's see what that looks like real quick. Okay. All right. So at this point, I'm going to be bringing down the x squared minus 6x blank equals 12y plus 51 blank. And we're going to use the completing the square process in order to put this equation in standard form. So that means I'll be taking half of the middle term's coefficient, taking half of that -6, which is -3, and then squaring that value. So squaring -3 will give us a +9 that we need to put in our blanks here. All right. Amen, amen. At this point, you can say that this is equivalent on the right side, guys, to 12y plus 60. You see that? And then factoring your perfect square trinomial that you have here on the left, we can say that this factors into x minus 3 squared. See, when you factor that perfect square trinomial, it's always going to be your variable and whatever half of the middle term's coefficient is. So we end up with our variable x, and then half of that -6 was -3, right? That goes inside of your binomial here when you factor that perfect square trinomial. But then in addition to that, remember that we should just have y minus a k value inside the parentheses. So that means that our common factor that we need to factor out, even if it wasn't in common, is that coefficient on that variable y. We need to factor out that 12, guys. So factoring out the 12, you'll have y plus 5. And now you have your answer. You have your equation written in standard form right here. It's going to be the quantity of x minus 3 squared, which equals 12 times the quantity of y plus 5. And this, guys, is going to be the standard form of your parabola, especially when you're dealing with conics, okay? So it's only because we're specifically dealing with conics in this section that it would be written this way. Because, of course, depending on the topic, the concept that you're dealing with, the standard form of a parabola will vary. All right. So you got to really know that, hey, we just got through covering conic sections, and therefore this is the standard form that we are going to be referring to, because unfortunately, guys, standard form is not standard depending on the textbook, the author, and the general concepts that you guys are covering. Obina says, I'm really glad I subscribed to this channel. I am glad that you subscribed to this channel too, Obina. And I'm grateful for anybody that is subscribing to Fort Bend Tutoring FBT, because we want to be able to reach the masses and share our knowledge with you guys. So thank you so much for being a part of that, Obina. Chosen Creeper says, me too. I appreciate all of you guys being a part of this process. That's right. And the growth of this channel. Absolutely. All right. So here we have our next problem, guys, that I want to share with you. Some more information just for you. Let's look at the original problem. With 45, guys, it says to classify the conic section as a circle, an ellipse, a hyperbola, or a parabola. So what I wanted to provide you guys is some good notes on how to identify what type of equation you're dealing with, what type of conic section that the equation is referencing. All right, it's referencing. Anyway, I can't talk right now. Referencing. You know what I'm talking about. So here we're going to be adding y squared to both sides. If we were to add y squared to both sides, this should look like a familiar form to you. In other words, by adding y squared to both sides, you should recognize this type of equation. X squared plus y squared equals to 4, all right, is the equation of a circle. It's the equation of a circle, okay? But the way you can determine that on your own, guys, is if you knew the following information right here. Check this out. In a general conic section, all right, in a general formula for an equation, if you have this setup here for a general conic, all right, an equation of this form, if A, okay, does not equal to 0 and B equals 0, or if A equals 0 and B does not equal 0, you're dealing with a parabola, okay? However, if A and B both don't equal to 0, but they equal to each other, you're dealing with a circle. So that's what happens here. Our A value is 1. Our B value is 1. They equal to one another. Therefore, it's going to be a circle because that A value doesn't equal to 0. It equals to 1. The B value equals to 1. And they're both the same value. So anytime that A and B value are both the same, okay, and they don't equal to 0, you are dealing with a circle. Good to know, right? Then, if you have a situation where your A value is less than your B value, or your A value is greater than your B value, and neither of them equal to 0, you're dealing with a hyperbola. You're dealing with a hyperbola. Or, if both the A and the B value are greater than 0, or both the A and the B value are less than 0, you're dealing with an ellipse. And, in addition to that, in a special case, if A equals to B and they both equal to 0, but C does not equal to 0, you're dealing with a hyperbola in that case as well. That's right. So Obina says we have a circle with a radius of 2. That's correct. That is correct, Obina, because you're using the center radius form of this circle, which is what I wrote it in, which is x minus h squared plus y minus k squared equals to r squared. All right. So basically, I use this form of the circle, this form of the equation, which is the center radius form of a circle, to identify that I was dealing with a circle. But even if I didn't know this center radius form, I could use this information here to identify which type of conic section that I was dealing with. So I know that I was a big, giant information dump on you guys, but I didn't want to walk away from this review without making sure that you guys had this information. All right. Obina says that she actually graphed it. The radius is literally 2. Absolutely. It sure is. I agree with you, Obina. All right. So there you go, guys. So if you didn't know this information, go ahead and later on after the stream has processed, go ahead and pause that so that you can go ahead and write down those notes on conic sections so that you can get that information done and done. All right, let's keep it moving, guys. That was problem number 45. The answer to this is a circle. I guess I should put that somewhere, right? Since that was what the question was. Circle is what that answer is. That's what type of conic section that we had. Circle. Done. That is problem number 45, guys, and we are now on problem number 46 as we have a logarithmic equation. We have a logarithmic equation, and I'm going to solve this a different way than I did the last problem in this review, guys. This one, I'm going to go ahead and use the conversion of a logarithm into exponential form. And just to remind you what that conversion is, it is if you have log base b of x equals to y, that this would be equivalent to b to the y equals to x. So this is a b right here, guys, if you didn't know that. There you go. So I'll be using this logarithmic conversion into an exponential form in order to solve this problem for problem number 36, this logarithmic equation. So my base here is 2, guys. So I can rewrite this equation as 2 to the 4th power equals the value of 5x plus 1. So this is how using the conversion between logarithmic form and exponential form can assist you. Amen, amen. And Treasure Ghost has this answer, which is 3. Let's go ahead and see if we can match Treasure Ghost's result. We want to see if we can match up Treasure Ghost here. TG in the house. 2 to the 4th power, guys, is 16. So we have 16 equals to 5x plus 1. If we were to subtract 1 to both sides of the equal sign, you will have 15 equals 5x. You'll then divide both sides by 5, and x equals 3 if and only if our value does not violate the domain of our equation. Remember, guys, when you're dealing with logarithms and natural logarithms, you cannot take the log of a negative number, and you can't take the log of 0. You can't take the log of 0 or a negative number. So because of that, you may have an extraneous solution. So you have to test your result before you claim it. All right. So you have to make sure that when you plug in 3 into the quantity here, then you're going to have 5 times 3, which is going to be 15. 15 plus 1 is 16. And that means that in this case, this answer is just fine because you end up taking the logarithm of a positive number, which is the only values that you can take the log of. You can only take the logarithm of positive values. So therefore, if this ended up being a value that when plugged in would generate a negative number or 0, we would exclude it from our solution set. All right. However, in this case, it's just fine. All right. But you have to make sure that it's going to be fine by plugging it in to make sure that you have not violated the domain. Amen. Amen. There you go. Abina says that she forgot about the domain. That's right. Do not forget about the domain of the original function. You have to keep that in mind. You can't just blindly go in and solve the problem without keeping the domain in mind, because you may end up with an extraneous solution. And you've done all that good work and then don't have anything to profit from because you didn't verify your result at the end. You have to verify that you're taking the log of a positive number in order to claim it as a solution. All right. Good deal, guys. See, we're getting some good stuff, some good practice in before you guys, hopefully before you guys take your final exam for Algebra 2. Keep in mind also, guys, that for those of you that are going to be eventually going to college algebra, that Algebra 2 and college algebra are the exact same class, guys. There's hardly any difference between them. Hardly any difference between them at all. So when you're preparing for Algebra 2, you're also preparing for your college algebra class. You can swap out these final exam reviews and still be okay in either class. Good stuff. Obina says, when would you need to verify the solution doesn't violate the when would you need to verify the solution that it doesn't violate the domain? Obina, you would always verify the solution. And the only time you don't have to verify the solution is if you found out what the domain was to begin with. If you found out the domain at the beginning of the problem instead of at the end, then you would know once you get to your answer whether or not that value lies within your domain or not. So one way or another, you're going to be dealing with the domain if you're going to get the right answer. All right. So I would suggest, so I do it sometimes at the beginning. I do it most of the time at the end. But it's up to you as a math student or a mathematician as to how you want to go about doing that. The wisest math students do it at the beginning. All right. But I'm lazy, so I always do it at the end. All right. But if you want to be really, really wise about it, it's best to be aware of your domain to begin with before you even continue, so that anytime you come up with multiple solutions, you can quickly identify what's going to be extraneous and what's not going to be extraneous. But I'm a lazy student. So therefore, I usually will do it at the end. But it must be done, whether it's beginning or the end. So keep that in mind. All right. We have problem number 47, guys. Good question, Obina. It says to find the equivalent in A plus BI format, guys. So this is the standard form of a complex fraction. And we have imaginary numbers in the denominator. And it's not proper to leave an imaginary number in the denominator of a rational expression. Okay? You're not going to do it. Don't do it. So how do we go about doing that? We rationalize the problem. And we can rationalize the problem by using the conjugate. Remember that word that we dealt with earlier today? We had the conjugate in one of our problems. Well, that was dealing with square roots in the denominator, or radicals in the denominator for that matter. But now we'll be using the conjugate of 2 plus 5i to eliminate those complex numbers in the denominator. So you'll multiply by 2 minus 5i. In order to find the conjugate, you simply change the sign on the second term. In order to find the conjugate, you simply change the sign on that last term in the denominator in this case. All right. And from here, we will be getting our arrows popping, guys, as we multiply these binomials together. So in other words, this is going to become 3 minus I times 2 minus 5i. All right. Let's go ahead and fix that I because this I is merging with my number 5 there. Didn't want that to happen. And we have the quantity of 2 plus 5i times 2 minus 5i. Amen, amen. And then we will go ahead and complete this problem. Raul has his answer already. Now, remember, Raul, you don't have your answer completed unless you put it in A plus BI format. Okay? So it has to be, those two values must be separate from one another. You cannot have, unless you already have it. You may already have it separated from one another. Let me go ahead and check my answer, Raul, first, okay? So we'll have 3 times the 2 is going to be 6, guys. The 3 times negative 5 is negative 15i. We have negative I times 2 is negative 2i. We have negative I times negative 5i gives you a positive 5i squared. This is all going to be over. 2 times 2 is 4. 2 times negative 5i is negative 10i. 5i times 2 is a positive 10i. 5i times negative 5i is negative 25i squared. And then we'll be combining our like terms as well as recognizing that I squared is equivalent to negative 1. So that is something to keep in mind, that I squared is equivalent to negative 1. Let's fix this 1 here. Can we fix this 1? Doesn't look like we can fix this 1 today. All right, that's going to have to do for that negative 1. There we go. So now we'll have 6 minus 17i plus 5 times negative 1. And then in the denominator, our middle terms will cancel out. We'll have 4 minus 25 times negative 1, like so. From here, we'll be going ahead and simplifying further by ending up with 6 minus 17i minus 5 over 4 plus 25. So that means that our result here is going to be 1 minus 17i all over 29. But this needs to be separated into A plus BI format, guys. So your answer here is going to be 1/29th minus 17/29ths I. And this is going to be the answer in A plus BI format. So bottom line, guys, you need to separate the real number from the imaginary number. It has to be written as 2 separate values so that, once again, if you're going to introduce yourself to another person, you want to introduce your real friends to them before your imaginary friends. All right? Otherwise, you won't have any friends. There you go. Even your imaginary friends will be upset with you. Just saying. So here we have problem number 47 worked out, and we put our answer in A plus BI format, and Lewis has his answer correct. That is correct. And Raul understands fully what I'm letting him know about problem number 47. Good job. No problem, Raul. Here to help, sir. I am here to help. Absolutely. So let's move on to our next problem, guys. This is going to be the last problem for us today. All right. However, this last problem is really going to be 2 problems, because I'm going to show you how to do this problem 2 different ways. You hear me? I'm going to show you 2 different ways to do this problem. All right. So we are asked to find the vertex of this parabola. And we're going to be using completing the square in order for the first way, for the first process, the first method, the first strategy that I show you guys. That's right, 2 different ways, Dan. I'm going to show you how to find the vertex of this parabola 2 different ways. You got it. The first way is going to use completing the square. So what you want to do is you're going to be isolated to working on only one side of the equal sign here. All right. And what I'll do is I'm going to rewrite this by, first of all, factoring out 3 from the first 2 terms of this equation. I'm going to factor out 3. I'll be left with x squared minus 2x. Go ahead and write a blank. Then I'll have plus 1 and then a blank. That's what we're working with. Oh, yeah. Complete the square on the quadratic expression within the parentheses. You'll do that by taking half of negative 2, which is negative 1, of course, and then squaring that value of negative 1, you'll get positive 1 here. However, since we're on one side of the equal sign and we will not be messing with the left side, that's going to remain to be a y. We need to offset this 1 that we just inputted into the problem. See, the equation has to be equivalent to our original expression here, our original equation. We have to keep balance here. And we just added an additional term to this problem. We added a 1. That 1 wasn't originally there. So we need to find out what this true value is and then offset it to keep the equation equivalent. So how do I do that? We need to recognize that even though we put a 1 here in this blank, that true value is actually 1 times 3. So this real value of placing a 1 here within the parentheses is actually akin to adding 3 to the equation. So to offset this 3 that we just added to the equation, you will be putting a negative 3 here in the blank here. That's right. And now we're going to factor this perfect square trinomial and combine our like terms right here. So you'll end up with y being equivalent to 3 times the quantity of x minus 1 squared minus 2. And this is your parabola in vertex form. And with this equation written in the vertex form of a parabola, we can go ahead and write the vertex now, because the vertex, guys, is going to be HK. Notice that you'll need to take the opposite of that value inside the parentheses. So the x value of your vertex is 1, whereas the k value, the y value of your vertex, is going to be negative 2. And so we find that our vertex is 1, negative 2, and done. That's it. We are going to red cube it. Is that what you're saying, Chosen Creeper? We're going with the red cube today? All right, let's go ahead and get this red cube underway, sir. Red cubing it. There you go. We got that red cube today, sir. There it is. Kaylee says, do I have an Algebra 2 playlist? The answer to that, Kaylee, is yes and no. Remember earlier I said that Algebra 2 is equivalent to college algebra. So you could use the college algebra playlist for your Algebra 2 class. That's what's up. Red boxing it. So Kaylee, use the college algebra playlist. I just created it the other day and I'll be adding to that over the summer. All right. In fact, guys, that's what our near future live streams will be about. It will be about concepts from college algebra. And I will be doing those once a week. So this is going to be the final exam review for now. All right. I'll be doing other classes probably at the end of another semester. Well, let's say the end of the fall semester, probably. I'll be doing some more final exam reviews. All right. For other courses. All right. But for right now, that's going to finish up our final exam series for Forbidden Tutoring for this season. Let's put it like that. But the live streams will be weekly. All right. They'll be once a week because I'll be providing more studio videos for you guys. All right. Although I love chiming in with you guys, I can't make any errors in the live stream because it is a pain when I do so. So I'm going to be doing some studio videos for you guys and be doing those once a week, hopefully, as well as weekly live streams on college algebra, aka Algebra 2 content, Kaylee. So that's what we'll be doing over the summer. All right, so hopefully you guys can chime in and join us for that, because that should be fun as we tackle different concepts in college algebra together on a week-to-week basis. All right, so look forward to those. I'll be putting up the content. I'll be putting up a reminder, there you go, for that next live stream soon as I identify what the first video will be about. Okay, so just to let you know. So that's the first way to find that, guys. I promised you 2 ways, correct? So the second way is on its way, and here it is right here as we find the vertex of this parabola using the formula for the vertex. The vertex formula is right here. And what you're going to be referring to, guys, is having your quadratic equation in standard form. In other words, this form right here, the ax squared plus bx plus c form, which is generally called the standard form, all right, or general form of the parabola. Once you have that, you identify what the a value is, which is the coefficient of that first term, the b value, which is the second coefficient, and you use these values to create the h value. In other words, to evaluate what our x value of the vertex will be. Remember that vertex is going to be in the form of hk. So this formula tells you how to find that h value. In other words, h will be equivalent to negative b over 2a, which in this case is going to be the opposite of negative 6 divided by 2 times 3. Well, when you simplify this, what do we get? We get a positive 6 over positive 6, so that means that our x value is 1. Remember, that's what we had in our previous example. We said that the vertex would be 1, negative 2, right? So notice that we quickly identified that the x value was 1 already by using the vertex formula. From here, guys, we can then find out our k value by plugging in 1 into the original function. So because we found out that our x value was 1 for the vertex, we can plug this into the original function, the original equation, to find out what the y value will be. So plug that in, so you'll rewrite it as 3 times 1 squared minus 6 times 1 plus 1, and then simplify this in order to get the k value of your vertex. This gives you 3 times 1 minus 6 times 1 plus 1. From there, you'll have 3 minus 6 plus 1. And then simplifying this further, we have 3 minus 6, which is negative 3. Negative 3 plus 1 gives you negative 2 as your result for the k value. And then with their powers combined, you end up with the vertex of this parabola, which is 1, negative 2. And now we will red cube it. Ladies and gentlemen, go ahead and put that in a cube. There we go. Bam, bam, bam. There we go. We red cubed it, chosen creeper, just like that, guys. And that completes problem number 48 twice. So which version did you prefer, guys? Did you prefer doing it with the completing the square process? Or did you prefer the vertex formula? And for those of you that are so gung-ho on saying, oh, well, Mr. Witt, clearly the second way was faster. Why would I ever want to do it the first way? Well, there's 2 things. You want to know whether or not you can apply the completing the square process to this, because you may be asked to write it in this form, the vertex form. So by completing the square, it helped you write it in this form right here. So if the question said write the parabola in vertex form, you'll need to know how to complete the square, right? That's one reason for knowing that. Another reason for knowing that is because you can identify quickly the transformations that are done to this parabola here. For instance, the transformations is that this has a horizontal shift 1 place to the right. It has a vertical shift down 2 places. It has a vertical stretch of 3. And I can quickly identify this by looking at the vertex form of the parabola. Exactly. Chosen Creeper says, well, after all, I'm new to this. No problem, Chosen Creeper, because there is more information on graphing, all right, vertical parabolas. There's a video for that, and there's also a video for transformations of functions. So all of that refers to problem number 48. So you can get some more heads up information about that. So, ladies and gentlemen, this has been Mr. Witt with Fort Bend Tutoring. As always, please rate, comment, and subscribe. And as always, if you're able, please donate, as that helps us bring you more math tutorials free from Fort Bend Tutoring. And I appreciate all of you guys joining me today. Let's go ahead and show you some love, guys. I appreciate Hassan coming through, Chosen Creeper coming through. We also had Kaylee, of course. What it do, Kaylee in the house, guys. Lewis came by, Nita came by, Dan, Raul, Treasure Ghost, Angry Hermit. We have you in mind. That's right. Just Chris was here. We also had Zenobia coming through and others. Michael Bob was in the house. Michael Byrne was in the house. And we had so many other people chime in with us today, guys. I appreciate all of you stopping by and showing your love. Jamila was in the house. That's right. And Treasure Goes TG, of course. And guys, just keep in mind that I'm always going to be coming here, bringing you free content because that's what I love to do. I love sharing my knowledge with you, and I love you sharing your time with me. So let us keep us in mind and click on that bell icon so you can be notified when we upload new and fresh content from Fort Bend Tutoring. Peace.
Thanks for watching. We appreciate you hanging out with Fort Bend Tutoring. Like the video, comment, and subscribe. Hit up our website, tutoringmath.net, and set up a private tutorial with me and FBT. Oh yeah, baby. Comment and subscribe.